Okay, so we're using RobotC virtual worlds for the EV3 robot, and hopefully you've gone through the getting started tutorial. But just in case, remember that under Window, we would say go to Select Virtual World to use, and we want the challenge pack for EV3. And under Robot, compiler target should say Virtual Worlds, not Physical Robot. We want Virtual Worlds. And under platform type, we want EV3. If EV3 is not selected, we can go down to Lego Mindstorms and select EV3. So we're going to be dealing with adjusting speed in this tutorial. So I'm going to go to File and then Open Sample Program. And under EV3, we want Simple Behaviors. And we're going to select forward and backward. Okay, so let's talk about this program. First of all, this stuff at the top, you're going to ignore. This will be sort of done for you. The EV3 Rembot is a preset of motor selections where it names the motors and attaches the motors to the correct port so that you don't have to worry about it. We'll take a real quick look at that. Where that's going to fall under is motor and sensors setup. And so if we look at the motors, you can notice that it is named motor B left motor and is named motor C right motor. It has the motor attachments then are into ports C and B. Again, we don't really need to worry too much about that, but I will touch on that when we're going through the program. Okay. Ignore the top. This just sort of changed what it looks like, even though it really didn't change the code. Remember, task main we're going to see on every program. Doesn't really mean anything. We don't want to change it. All code is going to be enveloped by these curly brackets, and then units of code are enclosed in between a closed bracket and an open bracket. So let's talk about the various parts of this program. SetMotorSpeed does exactly what it says it does. It's going to set the motor to a particular speed. Remember when I opened the window above, it named one of the motors left motor. If you ever do this yourself, whatever you type in the motor and sensor setup must be exactly the same as what it looks like in the code, including case sensitivity. So left motor, and then this is setting the speed for the right motor. Here's what's really important, this number. 50 merely means 50%. So this is setting the motor speed of the left motor to 50%. This is setting the motor speed of the right motor to 50%. If both motors go the same speed, the robot will go straight ahead. Sleep is done in milliseconds, and this is, so 3,000 milliseconds is really 3 seconds. We don't want to go that far, so let's just say 1,000 milliseconds. Now, this second little part of the code sets the motor speed of the left motor to 0 and sets the motor speed of the right motor to 0. What will happen? The robot will stop. For how long? Sleeps for 2,000 milliseconds or 2 seconds. Let's drop that down to 1,000 milliseconds or 1 second. And let's suppose we want to go backwards. Then we're setting the motor speed to -50. The negative number makes it go backwards. If we set both motors backwards at the same speed, it will go backwards in a straight line. And I'm going to change that to 1,000 because we're going to add one more thing to this. I'm going to select all of this, Control C, and then Control V, and I pasted the same thing twice. 100 would be 100%. That's full speed. And then let's do one last thing. Here we were going backwards. I'm going to Control C, Control V, and change one of the negatives to a positive. And if one motor is going forward while the other motor is going backward, the robot will spin. And if you want to do any kind of turn, the way you turn with these robots is change the speeds. If the speed of the left motor is different from the speed of the right motor, it will turn. The more different the speeds are, so this is positive, this is negative, that's going to be very different. You're going to have a hard turn. But if these were pretty close, like 50 and 45, positive 50, positive 45, that will turn, but not much. If I had 50 and 0, that will turn, not as much as a spin, but it's called a point turn. But in this case, negative 50 means one motor's going forward 50, one's going backward at 50, and it will spin. So at the end, when we have our program done correctly, I'm going to File. I am saving this to my desktop in a separate folder. Calling that adjusting speed and turning. After we save it, I'm going to compile it. Then we're going to download. Let's click on the home. And we're still going to mess around with our first program. And we'll say Start Challenge. And what should happen? Think forward at 50, then stop for a little bit. Then I believe it was forward at 100, which is full speed, then backward, then turn. Let's see. Forward, stop, backward, turn. Try this again. Forward, backward, turn. Okay.